Hello everyone, welcome to my video series on molecule simulation using Gaussian software package. In the last video, I have shown you how to draw a IR frequency, or in other words, a vibrational frequency curve. And in this video, I will show you how to analyze the density of states of a molecule. To do that, you have to first go to the Gauss app. Okay, so here you have to open the frequency file or frequency optimized file. This is the file. Okay, so you can see that these options are available. So for higher frequency, I have already shown you. You have to select frequencies, and also you can vary this starting and ending point of frequency, which is in the x-axis of the plot. And now, if you wish to have the density of state graphs, then you have to go to orbitals. So in the most of the cases, we find the density of states, more specifically, the space between the energy gap between the highest occupied molecular orbital and the lowest unoccupied molecular orbital between -10 to 0 electron volt. So I am setting this to from -10 to 0, and then I will create the graph. Okay, so maybe there is a large homo-lumo gap, which is a large band gap present here. So I'm going to set the range from -20 to 0 electron volt. And now you can see that the large gap between the molecular orbitals. The virtual orbitals are representing the lowest unoccupied molecular orbitals, which are not occupied, and these are representing the occupied orbitals. There is a huge band gap between the valence state and conduction state of carbon dioxide. This means the energy gap is very high, which is expected, and this is about 10 electron volt, more or less. So this is it. This high band gap shows that carbon dioxide is an insulator, which is obvious. And in this way, we can just find the density of states diagram. And now, if you want to get the raw data of this plot, you can just go to the Gauss sum folder and you will select this DOS spectrum file they have given. So you can select all of these and just Control C, copy, and then I will paste it in the Excel sheet. Here I'm taking another Excel sheet. Okay, so you can paste it here, then you will find it in this way. So using these files, this column is not necessary. You can delete this column. This column is also not necessary. So these are the value for the density of states. In this case, these two columns. The first column is for energy and the second column is for density of state spectrum. And if you want to compare the DOS spectrum of different molecules, then you have to set the range in a fixed energy, because it's important to have the same value along the x-axis while you are comparing. That's the case. So that's all. And I want to remind you another thing, that when you will run another file in the Gauss sum app, these two files will be replaced by the latest values. So to avoid these circumstances, you can rename the files. For example, I can rename the IR file as IRCO2 and the DOS spectrum file as DOS CO2. And now if you open any other file in Gauss Sum app, then this will not be replaced, and a new file with the same generic name IR spectrum and DOS spectrum will appear for that molecule. So in this way it works. So that's all for this video. Hope that I will see you soon.